today we are going to play with numbers. Let us do it right. Today we are going to learn about significant figures and rounding off. So in measurements. So till now, what are the things we have learned? We have learned about physical quantities. So what are they? Fundamental quantities and derived quantities. We learned about the 7 fundamental quantities and also we learned about the SI systems where the standard units for the 7 fundamental quantities are raised from. Then later we discussed about errors. So errors taken place in different instruments and how to eradicate it. What are the types of errors will be committed in taking measurements and all we have learned, and also we have learned the formulas for eradicating the errors. And we learned a very important topic, that is propagations of errors in addition, subtraction, multiplication, divisions and power. So it is a very important topic. Error is a very important one and which will be asked both in your state board examinations as well as in your in-based examinations. Alright. So some of the students have shared me that they have clearly understood about propagation of error. Very good. So thank you for your encouragements too. Right? Now we'll go into it. So now first here we are going to learn about significant figures. So what does that? Figures means what a number can be represented in terms of what? Figures. So what we are going to say? So the digits tells us so number of units reasonably sure of having counted in making a measurement is called as what? Significant figures. We use various numbers in taking a measurement, right? So doing a calculation or taking a measurement, we'll use various types of numbers, right? Decimal numbers, fractional numbers, whole numbers, like that we'll use various types of numbers. So we'll take various types of values of measurements and we are going to say that so which value is reliable to it, which value is uncertain to it, right? So that is called as what? Significant figures. So we can say that a number of meaningful digits in a number. So which is valuable? I'm saying I'm giving you 0 chocolate. Is it any meaningful? Is that? What I have given to you? Nothing. Right? If I give 10 number of chocolate, if I say that 10 is a valuable one, we can able to count 1, 2, 3, like that we can easily able to count the numbers. So that is called as meaningful. If I am saying I am giving a decimal number of chocolate or a 0 number of chocolate, infinite number of chocolate, we are not able to have a countable one. So we say that is what? Called as significant figures. Am I right? So we are saying that the digit which tells us the number of units, how many units, right? So reasonably sure of having counted in making a measurement is called as significant figures. So we will define the significant figures as the digit that are known reliably plus the first uncertain digit. What is that uncertain digit? So if we take a calculations, anything means we will have first uncertainty. First 2 decimal points are certain. Then after that we can say it is what? Uncertain. Let us take an example. We know about the famous gravitational constant value, right? Gravitational constant given by Newton's, right? We know that formula F is equal to G into M1 M2 divided by R square. Is directly proportional to what? Product of a mass and inversely proportional to square of a distance between. That is your famous Newton's laws of gravitation. So that gravitational value, G value, gravitational constant takes the value of what? 6.67 into 10 power minus 7 Newton meter square kilogram minus 2. So the 6.6, the 6 and the 6 are reliable. So it is a very standard one. We are not able to change the value. If I am saying some other group they are giving 5.5, that's wrong, right? The 6.6 is always reliable, but the third digit, no, the 7th digit is unreliable. Sometimes we can say 6 or 7 or 8, so we are not able to have certainty in that value. It is not correct certain value. The second decimal can be somewhat variable, so it says that, but anyhow it is countable. Therefore, it says that this gravitational constant has 3 significant figures. So 1, 2 and 3. So these are said to be what? Significant figures. We are going to count the numbers and we are going to say so how many numbers are there, countable numbers are there in a number means in a meaningful manner. We are saying that as what? As significant figures. Can you able to get it? Right? So we are going to say that what is the significant figures? Significant figures are nothing but the number of meaningful digits in a given thing is called as what? Significant figures. Right? So we are going to learn the rules for giving what? Significant figures. What are the methods we have to follow in counting the significant figures. Then later we'll do a sum. Related to a significant figure means we have to keenly take into account of what? Significant figures into account in doing a calculation and how to write the result in terms of significant figures. So let us do it. Right? So what are the significant figures? If a number is given to you means the number of meaningful digits in a given number is said to be what? Significant figures. So after seeing this definition, you will see somewhat confused. By studying the rules for writing significant figures, you will find it to be very easy and it is very simple to calculate it. Right? We will do the rules for writing significant figures. Now we will see about the rules for writing the significant figures. So here I have written some of the numbers. So first, what is the significant figures? The number of a meaningful digit in a given measurement is said to be what? It is the significant figures. So we are going to count the reasonable meaningful number in a given digit. Right? So first we are having to see the rules for writing. So I have not written the rule statements, I have given the examples for it. Right. What is the first number? Is 1342. So all the numbers are said to be non-zero numbers. What do you mean by non-zero? So without zero, all the numbers are said to be what? Are non-zero numbers. So 1, 3, 4, 2 are said to be what? Non-zeros. Right. So therefore I can say that I can count all the values. 1, 3, 4, 2, all are a reasonable one, all are a meaningful one. Therefore, this number has what? 4 significant figures in it. So, what is the first rule? We are saying that all non-zero numbers in a given value is said to be what? Significant. So, all are non-zeros. 1, 2, 3, 4. How many non-zeros are there? 4 non-zeros are there. Therefore, the number of significant figures in the first number is what? 4 significant figures. Right? Is it clear? So, what is the first rule? All non-zero numbers are what? Significant. And second, so we are going to take 1, 2 and 8 are non-zero numbers. So between 2 and 8 we are having 2 zeros. Right? Then the second rule is the zeros between 2 non-zero numbers are also significant. Without the 2, if I take this 2 zeros, it is meaningless. Right? Therefore, 2008. So it is a meaningful number. So we are saying that what is the second rule? The zeros between 2 non-zero numbers are said to be what? Significant. Therefore, this number is also having 4 significant figures. 1, 2, 3, 4. As per the first rule, we are saying non-zero numbers are significant. So 1 and 2 are non-zero numbers. So it is significant. And as per the second rule, we are saying that zeros between 2 non-zero numbers are significant. Therefore, the zeros between 2 non-zero numbers are said to be significant. Therefore, the second number is also how many significant figures? It has 4 significant figures. Is it clear? 2 rules are clear. So 1, all non-zero numbers are significant. Number 2, the zeros between 2 non-zero numbers are said to be what? Significant. Good. Then we come for the third one. You have to look clearly about it. So I have given a dot at the end. Right? With the decimal, without decimal, you are going to see that. So if a decimal is given at the last, then all the zeros are said to be what? Countable. So without decimal point, we say that the trailing zeros. The trailing zeros means what? The zeros which comes after a non-zero numbers continuously. So we are said that as the trailing zeros. So the trailing zeros with the decimal point are said to be what? Significant, and without decimal point, we are saying that to be what? Non-significant. If the same number is given like this, 30700 without the decimal point means the 2 zeros are not reasonable or not meaningful. Therefore, only these 3 are countable. Therefore, we are saying that this number has 3 significant figures. But if a decimal point is given at the end, then it is meaningful. Therefore, we are saying that 1, 2, 3, 4, 5. Therefore, this number has 5 significant figures. So, as per the first rule, 3 and 7 are 2 or what? A non-zero number, so it is significant. As per the second rule, the zeros between two non-zero numbers are what? Significant. Therefore, 0 is also significant. Then as per the third rule, a decimal point with the zeros are said to be what? A significant. Therefore, 1, 2, 3, 4, 5. So how many significant figures are there? 5 significant figures are there. So what we are saying in the third rule, the trailing zeros with the decimal point are said to be significant, and the trailing zeros without the decimal point are said to be what? Non-significant. Is it clear? Suppose if the same value comes in terms of a measurement with a unit, then it is said to be a significant. We should not see about what? The decimal point or so. So here the meter, we are saying 30,700 meters. So 30,700 meters is a reasonable one. Therefore, this is also having what? 5 significant figures. Is it clear to you? I have given the same number as an example. See? So the same number with the decimal point means it has 5 significant figures, and the same number without decimal point means it is having 3 significant figures. And if the same number without decimal point, so but it has a measurement value, then it is said to be what? Significant. Is it clear to you? Yes, right? So that is it. So we have seen the 4 rules. What are they? The first rule is what? All the non-zero numbers are significant. Then what are the second rule is? The zeros between two non-zero numbers are said to be what? Significant. And the third rule is what? The trailing zeros. What does the trailing zeros mean? So continuous zeros after a non-zero number is said to be what? Trailing zeros. Like a train, it is continuously 0, 0, 0, 0 coming. Means to call that number is what? Trailing zeros. So the trailing zeros with the decimal points are said to be significant, and the trailing zeros without decimal point is said to be what? Non-significant. If suppose the value is given in terms of a measurement with a unit weight, then we should not say into a decimal point or without decimal point. We have to take the whole numbers and we have to count that the significance. And therefore this is also having what? 5 significant figures. Is it clear to you? Good. The next, we are going for now and now we have discussed a number which is greater than 1. Now we are going for a number which is less than 1. So if a less than 1 is like 0.00345. Right? So if a number is less than 1, the zeros left and right of a decimal point are said to be non-significant. Therefore, it doesn't have any meaning. So we cancel it. Therefore, there are 3 non-zero numbers are there. Therefore, the significant figures of that number is what? 3. Is it clear to you? So it is 0.00345. So what this rule tells to us? If a number is less than 1, the zeros left and right of a decimal point, left and the right of the decimal points are said to be what? And non-significant. Therefore, we should not take into account, we should not count the number. Therefore, we are counting only the 3 non-zero numbers. Therefore, we are saying that has what? 3 significant figures. Right? If the number is greater than 1, right, then the same thing, what it is, but decimal point is that, it is similar to this manner, but here if the number is greater than 1, then it is said to be what? Significant. The decimal point left and right of the zeros with the decimal points are said to be what? Significant. Therefore, this number will have what? How many significant figures? It will have 4 significant figures. Right? So if a number is less than 1 only, we have to see that the decimal point left and right of the zeros are said to be what? Non-significant. If the number is greater than 1, the zeros, the left and right of the point is said to be what? Significant. So this is less than, this is greater than 1. Therefore it is all. We can say that the decimals with the zeros with what? Decimal points are said to be what? Significant. Therefore, so greater than 1 means we have to calculate. Lesser than 1 means we should remove the zeros. Is it clear? Right. And what is the last one? See that it is again less than 1. Right? So less than 1 means what? The 0 or the 0 is non-significant. But this is what? Decimal point with the trailing zeros. So decimal point with trailing zeros are what? Significant. Therefore, 1, 2, 3, 4, 5. Therefore, this has how many significant figures? It has 5 significant figures. Right? Is that clear to you? Right. Then we come for the 8th one. What does the 8th one says? If whatever be the unit has been changed, the significant number will remain the same. It will let's take an example. 1.53 centimeter. 1.53 centimeter means what? So all are non-zero numbers. Therefore, 1, 5 and 3. There are 3 significant figures are there. So we are saying this is what? 3 significant figures. So if the centimeter has been written in terms of meter, 10 power minus 2, then the value is what? 0.0153. Right? Then what is the condition is the number is less than 1. Therefore, the zeros left and right of the decimal point is said to be what? And non-significant. Therefore, it has 1, 2, 3. Again, the number is what? 3. Then if it is written in kilometer, again the number is less than 1. All the zeros to the left and right of the decimal points are said to be what? Significant, non-significant. Therefore, 1, 2, 3. Therefore, it is also having how many significant figures? It has a 3 significant figures. Right? Is it clear to you? So whatever be the unit, the significant figures will remain the same for a given number. That is the rules for writing what? Significant figures. So while writing the significant figures, we have to keep in our mind these 8 rules. So again, we will recall that one. Yes. Let us start. What is the first one is? All non-zero numbers are what? Significant. What does non-zeros means? Zeros, that is number without zero, right? Without zero, all the numbers are said to be what? As significant. So therefore, it has 4 significant figures. What is the second rule is? The zeros between 2 non-zero numbers are said to be what? As significant. And what is the third one is? The zeros, trailing zeros with the decimal point is said to be what? Significant. And if the same number has been written in terms of a unit, then it is said to be what? Significant. And the trailing zeros without a decimal points are said to be what? And non-significant. Right? The next is what? A number is less than 1. So zeros left and right of the decimal points are said to be what? And non-significant. And if a number is greater than 1, the zeros left and right of the decimal points are said to be what? Significant. Right? Therefore, we are writing the same rules, and if the unit changes, there will be no change in the number of significant figures. Right? So while writing the significant figures, we have to very much keen about what? These 8 rules. Now let us do an example problem which is given in your book, that is example 1110. You are going to tell the answer, right? So what are the rules that we follow and how many significant figures are there in that, right? So what is the first one? So it has 1, 2, 3, 4, 5, 6. Right? What are the numbers? What is the significant numbers are there? So we have to take the first one. So there are 2 non-zero numbers. It is significant. And the zeros between 2 non-zero numbers are significant. But the trailing zeros without a decimal point, there is no decimal point at that point, right? So this is said to be non-significant. Therefore, what is the number at 1, 2, 3, 4? Before the number is what? Answer is what? The first answer is 4. The 4 significant figures. And next is what? Again 400. Right? So again the same thing. Trailing zeros. Therefore it has what? 1 significant figure. For decimal point is 10, then it is said to be what? A 3 significant figures. Without a decimal point, it has how many significant figures? It has 1 significant figures. Then what is the third one? The number is less than 1. So less than 1 means what? All the zeros are not meaningful. Therefore only 1. Therefore how many significant figures are there? There are 1 significant figures are there. Right, good. Then comes the fourth one. It is what? 5213.0. Therefore it has how many? So decimal point with the zeros are said to be what? Significant. Therefore 1, 2, 3, 4, 5. So that's how many significant figures are there? 5 significant figures are there. Right? Then fifth one. So it is written in terms of scientific notations. Instead of going for a trailing zeros continuously, 0, continuously, it has been raised to the power of 24. We should not think, right? So if you multiply it, it becomes a trailing zeros. Then it is not without decimal point. Means it is said to be what? Non-significant. Therefore, this should not be taken into account. So only these 3 numbers have been taken into account. Then there are how many significant figures are there? 3 significant figures are there. If you multiply also, you can find the same value. If you multiply 10 over 24, zeros means what? The decimal point will vanish. So 2 decimal point will vanish, you have 22 zeros. The 22 zeros are what? Trailing zeros without a decimal point, right? We have not kept a decimal point at that point. So then it is said to be what? Non-significant. Therefore, how many significant figures figures. It is a 3 significant figures. Then come for the last one. It is a less than 1. So everything is what? So it is a non-meaningful. So it is 1, 2, 3, 4. It has how many significant figures? 4 significant figures. So once we keep our rules for writing the significance in our mind, we can easily able to write the answer. And this year, in a NEET question, they have been asked the same problem related to significant figures in your NEET examination. So it is a very simple one and very easy one. Once we have know about what? The 8 rules for writing significant figures. So remember that all non-zero numbers are significant. Zeros between two non-zero numbers are significant. And trailing zeros with the decimal point are said to be significant. And trailing zeros without a decimal point are said to be what? Non-significant. If that same number arises in terms of measurement with a unit, then it is said to be what? Significant. Right? If a number is less than 1, the zeros left and right of the decimal points are said to be what? A non-significant. If a number is greater than 1, the zeros left and right of the decimal points are said to be what? Significant. And if a unit changes, the significant value will never change. So that is that. In the scientific notations also, there will be no change in the significant number. So we call this as what? Significant figures in a measurement. So the number of meaningful digits in a given number, in a given measurement is said to be what? A significant figures. Am I right? So we have clearly understood about significant figures. Now we will move on to another number problem, that is rounding off. What does that rounding off means? So if you use a calculator, we will have infinite numbers. We will have 8 to 9 numbers we will have, right? So by writing the answer or doing the calculation with 8 or 9 numbers in the decimal, after decimal we are having 7 to 8 numbers mean, then it is very confusing and it is very tedious to do our various calculations. So in order to eradicate that, so we will round off it to a number. Then we have following certain rules in rounding off that number, right? So we are going to round it to 3 significant figures. We are going to round it to 2 significant figures. That means what? 2 meaningful digits or 3 meaningful digits. We are going to round it means we are going to follow some rules in rounding off. That is called as what? Rounding off. In order, instead of writing so many numbers in a calculation, we will write to a very meaningful and very prescribed number by keeping a rounding off in mind, and we call that as what? Rounding off. So let us learn about the rounding off. So we have learned about the significant figures and rounding off. So using that significant figures and rounding off, we are going to do some of the mathematical operations. So that is the arithmetic operation using a significant figures. So what we are going to do, it means we are going to do a simple addition and subtraction that we have been doing in your 6th to 10th standard or 11th standard, right? So the same thing. So in addition and subtractions, here I have taken 3 numbers. So one is 3.1 and 1.780 and 2.046, etc. Right? So these 3 numbers has been added and we found the answer to be equal to what? 6.926. How many significant figures are there? There are 4 significant figures are there. But what we are going to do, it means we are going to see the sum and we are going to check which is having a very least significant figures. So here how many significant figures are there? 2 significant figures are there. Here how many? It has 4 significant figures. Here it is having what? 4. And the result is having how many significant figures? 4 significant figures. But what we are going to do, it means we are going to write the answer in terms of a least number of significant figures. So which is having least number of significant figures? This 3.1, that is having 2. So it has a very least number. So we are going to round off our answer to our least significant figure value. So if rounding off it means what? We have to take 2 numbers, 1 and 2. We are going to see the third one. Third one is what? It is less than 5. So we are going to drop the number. Therefore the answer is becomes to be what? 6.9. So that is the thing we are going to follow it in what? So you are going to use significant figure as well as rounding off in doing the mathematical operations. So like this, they will give you 2 operations. They will give you 2 numbers or 3 numbers and they will ask you to add the number and they will ask you to round off without saying how many significant figures. So what we have to do? We have to check the significant figures of a given number and we have to round off the answer to the least number. So this is having least 2. If I see 7.1. That is the answer. Right? Is it clear to you? So we are using significant. First we are finding the significant figures of the given number and we are going to round off to the least significant number. Right? Similarly in terms of multiplication and division. So you have created two number. It is 1.21 and it is 36.72. It has how many significant figures? It has 3 significant figures. It has 4 significant figures. Right? So we are getting, if I multiply this number, we will get an answer like this. But the answer should be round out to least significant figures. That means what? 3. So 3 means what? 1, 2 and 3. And we are going to check the dropout number. The dropout number is less than 5. Therefore simply the number is dropped out and answer is said to be what? 4.44. 4.44. Right. Then if I divide these two numbers. So here how many significant figures are there? There are 4 significant figures. Here I am having 2 significant figures. So the answer is having how many numbers? 3 significant figures. But we have to round up to at least, means we have to round up to 2 significant values. Therefore this 1 and 2. So we are taking the value this 6. This is greater than 5. Therefore the answer will become to be what? 31. The answer will become to be what? 31. So that is said to be what? So arithmetic operations with the significant figures. It is very easy, right? So they will give you to calculate an area or a volume of anything and they will ask you to do what? Significant figures in answer. So we have to check which number is having the least significant figures and our answer should be with that same significant figures. So that is a mathematical operation which has been followed in what? In a significant figures and rounding off. So remember the rules and if the rules are remembered, the n number of sums has been given to you. It is very easy to do it. So it will be asked a simple 1 marks or 2 marks sums and it has been also a competitive based questions which has been asked in this too. Right? Right. Now we have completed main topic. Now we are going to a very important concept called dimensional analysis. Now we are going for a very important concept, that is dimensional analysis. Right? It is a very important one and you have to know it for all the concepts. If we are going reading for all the lessons, so we will continuously what if any definition is coming, means what we'll write? We will write about the formula. Right? After writing the formula, we will write the unit. Then we will say that the dimensional value for a certain quantities. Then we will go for whether it is a vector or scalar. So in physics, these 3 things forms a basic important things in all the lessons. If you learn any new definitions, so for that you will learn the symbol, then you will learn the formula. After learning the formula, you will learn about the unit and you know about the dimensional value and then you will say whether that quantity is a vector or scalar quantity. So for writing the unit as well as writing a dimension, so this concept helps us, right? So it plays a very important role in our physics and it is a very important part in for your competitive examinations also. Now we will learn that. It is a very easy and a very interesting concept, right? Now listen. So what is a dimensional analysis? First we have to know about dimensional analysis for the physical quantities. Right? So we know about various physical quantities or 7 fundamental quantities, 2 supplementary quantities and infinite number of derived quantities. So for all the derived quantities we are having some common dimensional values. So we are going to learn that. So before going to that we have to know about what is meant by dimensional formula and the equation. So what is a dimensional formula? Is nothing but we can say that how and which the fundamental units are procured to represent the unit of physical quantity. So how we are going to represent all the fundamental units in terms of physical quantity, we call that as a dimensional formulas. And what is a dimensional equation? Dimensional equation is nothing but we can say that the dimensional formulas are written in terms of an equation. We can call that as a dimensional equation. So what we are going to do? We are going to represent all the fundamental quantities in terms of a dimensional values. We are saying that as a dimensional one. And we are going to take some physical quantities and we are going to write the dimensional formula for that. Right? Let us learn that. Now we will see about these 7 fundamental units. What are the 7 fundamental physical quantities? Length, mass, time, temperature, electric current, luminous intensity and amount of substance. we learned in our starting of this lesson, right? So these are the 7 fundamental quantities, and these 7 fundamental quantities have separate dimensional values. Now we are going to learn that. We know that length has been represented in the symbol L and its unit is meter, and meter will be represented in terms of what? Small m. Here dimension means, if you are going to write a dimension means, we have to very much keep in our knowledge that we have to write only inside a square bracket. If I write simply with the capital L, it is not a dimensional value. So we have to write inside a square bracket. We have to use only a square bracket. We should not use any other form of a bracket. Right? That is the form of writing a dimensional values. So we say that for length it is L. So we have to enclose it in a square bracket. So that is a dimensional value for what? Length. Then mass. So mass will be what? Capital M. Then time. Time is what? Capital T. Then temperature. Temperature is here we have represent T. So we will not represent T here again. So we will say that it is capital K. Right? So this is a dimensional values we have to remember. How we are remembering the unit. Like length means meter, M. Then mass means kilogram, kg. Time means second. Yes. So we are remembering the symbols like that. We have to remember the dimensional values of these equations. Right? For length it is L. Mass M. Time T. Temperature Kelvin, capital K. Electric current will represent the unit ampere. Here and all we are using the first letter. For temperature and electric current we are using the letter of what? Its unit. Capital K, capital A. And luminous intensity is also what? What is the unit of luminous intensity? Yes, it is candela, right? So we will write it as CD. We will write it as what? Inside a CD. Or in some other notations it has been given as capital sign in a square bracket. Right? Everything, if it is a dimensional value, that should be inside a square bracket. Then amount of substance is mole, it is inside a square bracket, it is a mole. These are the 7 fundamental units and its dimensional values. Right? We will use these notations only, but major in things, we will learn everything in terms of mechanics. Everything we learn in terms of what? Mechanics. In mechanics, we will use mainly length, mass and time. So if we learn about mechanics in 11th standard, the complete volume 1 is going to explain you about what? A mechanics chapter. We are going to learn kinematics, laws of motion, work energy, power. So everything come under a topic called what? Mechanics. So in mechanics, we use a basic fundamental dimensions of what? Length, mass and time. And temperature. Temperature will come for what? So temperature we learn in the lessons called thermodynamics. So heat and thermodynamics is your 8th lesson, right? So in thermodynamics, if you are using any physical quantities, in that quantities in dimensions values will represent what? K, capital K inside a square bracket. Then electric current is ampere, you know that. So electric current and our ampere symbol, where it will come in? It will come in the chapter of what? Electricity. It will come in the chapter of electricity that you will learn in your 12th standard. Right? Then luminous intensity. Luminous intensity means what? It's the intensity that will come under the lesson of optics. Right? So if any quantities comes, then we can see this dimensional values. Right? Then amount of substance is more. So which is represented in your chemistry lessons or any chemical substances. Right? So that is your 7 fundamental quantities and its dimensional values. Most probably we will have length, mass and time. So we have to represent in terms of capital L, M and T, and everything should be enclosed in a square bracket. If you are not writing a square bracket and simply writing capital M, capital L and capital T, the dimensional notation is wrong. Is it clear to you? So that should be written only inside what? A square bracket. That is called as dimensional values. Now we are going to see for that how to write a dimensional values, right? So we will take a term velocity, right? I'll write it here. See that? Velocity. What is velocity is? You know about the formula for velocity. What does velocity stands for? So velocity is equal to, what is the formula I have been learned? So displacement by time taken. That's what velocity is equal to displacement by time taken. That is a formula. You have to know about all the terms, physical quantities and its respective formulas, right? So displacement represents what? It's a length. So
short points. This called as what? A shortest distance between two points are said to be what? A displacement. So it represents what? Length. Right? We have to understand like that. Time is t. Therefore, I can say that. So length means what? Distance is what? We know the unit. What if I want to write a unit? Displacement will represent in terms of meter and time will be represented in terms of second. So it will be written as what? Meter per second. So this is the value of representing a unit. Now we are going to write a dimensional value for that. So dimensional value means what is displacement? Displacement will come for what? It is a length. Therefore it will be capital L. We have to use a square bracket, right? So capital L by time. Time taken means what? We have to write time means what? Capital T. So if I want to write in the same form, I can write it as what? Capital L. We can write in the same term, right? Capital L and T power minus 1. Right? This is written as what? LT power minus 1. So that is the dimensional value for velocity. Is it clear to you? So we are saying that the length has been raised to the power of 1 and time has been raised to the power of minus 1. So like that we are going to represent all the physical quantities in terms of what? A dimensions values. Right? We are going to work out more number of cases. So now we are going to learn about the dimensional formulas for different physical quantities. It is very easy and it is very interesting too, and we have to practice this and have to remember it. Right? So we have learned about all the 7 fundamental quantities and its dimensional values. So we are going to use only the 7 fundamental quantities as a dimensional values, and we are going to write the dimensional formulas for these physical quantities. So here I have taken only 15 examples. So in your book they have given more number of things, and after completing it and after understanding how to write a dimensional values for a given physical quantities, you are going to try for all the physical quantities which has been given in your book. You should not see the answer. So you have to know about the physical quantities and you have to see the formula. I already said that by writing the unit we have learned about the formula for different physical quantities. So you have to remember that formulas, and from the formula you have to derive the physical quantity or derive the dimensional value for the physical quantity, and later only you have to check the dimensional value which is given in your book. If it is not coming to you and you will ask me, I will explain you again. Alright? Right. Now we'll see for that. So first thing, simple thing I have taken what it is. It is area. What is the formula for area? It is what? It is length into breadth. So you know that. It is what a simple formula. Length into breadth. Right? What is length? Breadth. Everything is length only. L only. Therefore, for this I can write L and here also L. Then therefore it becomes to be what? The answer is what? L square. So in our product the power will be what? Added over. So if it is the same term as that and we are multiplying, it means the power will get what? Added. So it has a power 1, this has a power 1. 1 plus 1, it becomes to be what? 2. So it becomes to be L square. Length into breadth. Is it clear? Then come for volume. What does the volume stands for? So volume is nothing but what? Volume means what? We can write length into breadth into height. We can write it. Right? Length into breadth into height. But length into breadth we are saying as what? Area. Therefore we can write another equation as what? Area into height. Instead of saying length into breadth into height, we are writing as what? Area into height. What is area is? Area is nothing but what? Length into breadth. What is the dimensional value for length is? It is L square. Then height is also what? It is L only. Therefore it is L. Therefore what is the answer will be? It is L cube. Remember it? In product the power will get what? Added over. The power will get added. Is it clear how to write? So the area is, dimension is L square. Volume is what? Dimension is L cube. Similarly, we are going to follow for what? Density. What is density? So density is nothing but mass by volume. So what is the formula for density? It is mass by volume. What is the value of mass? So mass is what? Mass is capital M. So we will get capital M. So inside a square bracket. Then what is volume? Volume we have calculated as what? L cube. We have written as L cube. Therefore it becomes to be, we can write it the same notation, L power minus 3. So that is a dimensional value for what? Density. Right? So density has a dimensional value m power 1, L power minus 3. Usually everything will written in terms of what? M, L and T. Right? So if we can write in 3 terms or we can write as a single term. Right? Here T is not there. We can write as L, M, L power minus 3, T power 0. Right? What is anything raised to the power 0 is 1. So we can write it or we can neglect it. That is not into account. Right? So usually everything has 3 terms. ML. If I want to write for L square, I can write this one M power 0, L square, T power 0. So M power 0 or T power 0 is what? 1. So 1 into L square is L square value. So if we know to write the dimensional values, directly we can write the values instead of doing for M and 0. But in order to do some sums, we need these 3 terms. Means we write as M power 0, L square and T power 0 in order to equate the same quantities. Right? So usually it will be represented dimensional values for all the physical quantities in terms of mechanics will be written in terms of what? M, L and T. Right? So we can write directly as a single term or we can write the 3 terms raised to the power 0. Is it clear to you? Right. Now we move for the last one, velocity. We already seen that. What is the velocity is? Velocity is nothing but it is a displacement by time taken. So displacement is what? It is length. So you can say the displacement is L by T. So we have to include the square bracket. The square bracket is not that. The dimension is wrong, right? Therefore, it becomes to be what? L T power minus 1. So that is the dimensional formula for what? Velocity. Right. Now we come here. Acceleration. What is the acceleration values? Acceleration value is said to be equal. I write it here. Acceleration is equal to velocity by time taken. Velocity by time taken. We have to remember that. What is the dimensional formula for velocity? We can directly derive velocity is equal to displacement by time taken and from that we can easily derive it. Otherwise, if we know the dimension for velocity, we can directly substitute. So if I say that I don't know about the velocity dimension, means I can write displacement by time taken. So our displacement by time taken, it becomes to be displacement by time square. So time into time, it becomes to be what? Time square. So you can see displacement is what? Capital L. Time square, it becomes to be what? LT power minus 2. Or we can say that it is LT power minus 1, this is T, when it goes up it becomes to be what? LT power minus 2. So that is the acceleration dimensional value. So you have to remember that. If I say velocity, what is the dimensional value? You have to say that it is a LT power minus 1. If it is acceleration, you have to say about what? LT power minus 2. Is it clear to you? Right? So we have column for area, volume, density, velocity and acceleration. Right? These are the common terms which we use in our daily physical quantities. Right? Daily one. Right? Now we'll go for a momentum. So momentum means what? Any change in the mass with velocity. So momentum will be given by what? Mass into velocity. Mass into velocity. What is the dimension value for mass? It is m. What is the dimension value for velocity? It is L T power minus 1. Therefore, we have got momentum dimension is what? M L T power minus 1. If M is there, L is there, it has been raised to the power 1. Right? If it is not there, if I want to write for here, I can say that it is M power 0, L T power minus 2. If M is written, then it is what? It is raised to the power 1. If it is not there only, then we have to say it is raised to the power 0. Is it right? So momentum is mass into velocity. Right? Then force. What is force formula is? Force is nothing but what? What is the force? Force is equal to mass into acceleration. Mass into acceleration. What is the value of mass? What is the dimensional value of mass? Yes, it is m. What is the acceleration dimension value is? It is LT power minus 2. LT power minus 2. So that is the dimension value for what? Force. So mass into acceleration. Mass is m. Acceleration is what? LT power minus 2. Is it right? Right. Then what is work? 8th one is what? Work. Work means what? What is the formula for work? Work is nothing but force into displacement. What is the value of work is? It is force into displacement. Force means what we have learned here. Displacement is L. So what is the dimensional value? So I can say that mlt power minus 2, mlt power minus 2 into what? Again what? L. So force dimensional value is mlt power minus 2. Displacement value is what? L. Therefore it becomes to be ml square t power minus 2. So that is the dimensional formula for what? Work. Is it clear? So is it simple to you? Can you able to write it? Now we have learned all the 7 fundamental dimension how to represent it, and we have learned the formulas for it. Then we have to check that. So the length belongs to which fundamental quantity, breadth belongs to what. So it represents length. So therefore we are substituting the value and we are writing the value inside a square bracket. Remember it, how to write only inside a square bracket, then only the dimensional formula is right. Now we come for the next one. Power. What is power is? Power can be said into work by time taken. So what is your power is? So we are learning everything in a 1 hour. We are saying that you are okay. Right? If you are learning within half an hour, thoroughly, you are a super genius. Right? So you are remembering everything inside. Within 10 minutes you are understanding everything. So you are super power. Right? So like that. Work has been done in your time. Work by time taken. So what the work we are doing it. It is said to be what? Power. What is the dimensional value of work is? So dimensional value of work is ml square t power minus 2. Right? So where we are at from? Force into displacement. Since we have doing it, we are directly substituting. Suppose if you don't know, directly power has been given work by time taken. Then what you have to do? What is the formula for work? You have to remember. Work is equal to what? Force into displacement. Again, what is the value of force? Force is equal to what? Mass into acceleration. So from that you have to work out. Is it? If I don't know the work dimension directly, then what you have to do? Work is equal to force into displacement by time taken. So time is a fundamental quantity. Displacement is a fundamental quantity. But force is not one. So force we have to derive. Again, force is equal to what? Mass into acceleration into displacement divided by time taken. Alright? Then what we have to do? So mass is what? Mass is m. Acceleration. Right? So we can write it, right? Here we can write as mass is what? Capital M. Acceleration is what? Lt power minus 2. Then displacement is what? L divided by 2. Right? Then what it becomes to be? It becomes to be m. 1 multiply comes, it becomes to add a L square, t power minus 2, when it goes here, it becomes to be what? Minus 3. So like that we have to derive it from one fundamental things to other. So directly if we know, we can substitute it. Otherwise we have to write the fundamental concept. Work is equal to force into displacement. I don't know about force dimensions also. Therefore we are writing as what? Force is equal to mass into acceleration. Acceleration into displacement. So mass I know, this m, fundamental. Acceleration we know it. Otherwise acceleration again becomes what? Velocity by time taken. Again velocity becomes what? Displacement by time taken. Right? So we can say that it is a into d by t. So since we know about, we have to know about velocity means lt power minus 9 and acceleration means lt power minus 2. That you have to remember, right? So we can directly substitute this value and we can write it. Here also the same thing. So it becomes t means what? If it is raised to the power minus, it becomes to be what? Minus 3. Is it clear to you? So everything we have to go for the fundamental quantities, and from the fundamental quantities we have to write the dimensional values. Then next is surface tension. What is surface tension? Right? We can say that force by length. Force by length. Everything we will learn it, right? So here we are writing the formula. Force by length. What is the dimensional formula for force? Mass into acceleration. So mass means what? We can write it as what? We can write it here again. Right? What is the force? Force is equal to mass into acceleration divided by length. Acceleration value know it. What is that? lt power minus 2. Then divided by l. Right inside a square bracket. If it goes up, it becomes to be what? L gets cancelled. It becomes to be t power minus 2. So that is the dimensional value for what? surface tension. So length and length gets cancelled. It is power 1, it becomes minus 1 means it becomes to be what? 0. Or I can write as what? Here at power 0. So there is no meaning in it. You can directly write as what? M t power minus 2. Right? Right. Till now we have completed. Now we are going for a different terms. So it is angular velocity. So what is velocity? So velocity, acceleration and displacement, everything is a linear one. If we go for a rotational concept, then that the terms comes under angular velocity. We will use the same formula, right? So what is velocity is displacement by time taken. Here angular velocity means angular displacement by time taken. So angular displacement means if I say a circle, where a circle is there means the central point is starting here. So for some time 2 seconds or moving here means this distance is said to be angular displacement. Right? So this distance is said to be what? Angular displacement. And angular displacement will be represent a symbol called theta. And displacement means in linear term we say it as meter. Right? But in angular displacement we say in terms of a radian. So radian is not a fundamental quantity and we will not use a radian in the dimensional values. So angular, if I write it is angular velocity is nothing but it is angular displacement by time taken. Angular displacement by time taken, and that angular displacement has no unit in dimensions. It has its unit is it has a unit. Its unit is radian, but it has have no dimensional values. Therefore, the dimensional value is only time taken, and we will say that t power minus 1. Is it clear to you? If I say angular acceleration, so angular acceleration means what? Angular velocity by time taken. Again, t power minus 1 becomes to be what? T power minus 2. That L will not come. If I say normal velocity, L t power minus 1. If it is an angular velocity, it is for t power minus 1 because angular displacement is set in terms of radian and radian doesn't have any dimensional representation. So we will not write that equation, right? So we call that also what? T power minus 1. Then next comes what? Surface energy. What is surface energy? We can say that it is work by area. So what is surface energy? So I can say it is what? Work by area. So what is again? Work is equal to what? Force into. What is work is equal to what? Work times force into displacement by time taken, or force can be written as mass into acceleration into distance divided by time taken. Right? So directly we can say work is what? What is the formula for work? Dimensional value. We can say that m L square t power minus 2 divided by what is area? Area is what? Length into breadth. L square inside a square bracket. It will get cancelled. Then what is the dimensional value? The dimensional value is m t power minus 2. M t power minus 2 is the dimensional value for surface energy. Right? Then comes charge. What is charge? Charge is nothing but charge anything. We can say representing symbol of Q. So Q is equal to current into time taken. And current will be represented in terms of I into T. This is symbol, right? Not formula. So current into time taken. Current means what? Electric current. Electric current dimensional value is what? Yes, it is capital A. Therefore, the dimensional value will be, you can say that it is capital A. Current to current ampere is A and that AT. So what is the formula for charge? Charge is equal to current into time taken. So dimensional value of current is ampere. So capital A. And time is what? Capital T. Therefore the value is what? AT. Is it clear to you? Then comes what? Heat capacity. What is heat capacity? Yes, heat capacity is nothing but heat energy by temperature. So what is the formula? Heat capacity is nothing but what? Heat energy by temperature. What is heat energy by temperature? Energy. Energy is nothing but the same. Heat energy is said to be what? Work only. Heat energy or what? So temperature will be represented in terms of what? Temperature will represent in terms of Kelvin. Temperature will represent in terms of Kelvin. Energy and work has the same unit. So if I say energy or if I say work, it has the same dimensional value. What is the dimensional value for work? ml. So what is the value? ml square t power minus 2. ml square t power minus 2 is the heat energy. Energy and work has the same unit and same dimension. Right? So what will be represented in terms of joule? And energy will what? ml square t power minus 2 divided by temperature. What is the dimension for temperature? It is Kelvin, K. Therefore, what is the dimensional value? So, dimensional value is ml square t power minus 2 into k power minus 1. So, that is the dimensional value for what? Heat capacity. So, dimensional value for what? Heat capacity. Remember that heat energy and work has the same value. Right? So, we are writing it for work and we are writing it in terms of Kelvin. Right? So, the last one is gravitational constants, which we will use it. So, we will write it here. Listen here. So, what is gravitational constant? We know about the famous Newton's gravitation value. What is the famous Newton gravitational value? So, force is directly proportional to the product of masses and inversely proportional to the square of a distance between them. Therefore, I can write it as what? So, I can write it as F is equal to, or F is equal to the proportional sign becomes to be what? Gravitational constants. G into, so that the proportional product of masses. M1, M2 divided by R square. Right? So, we want to find the gravitational value constant. So, we can write it. G is equal to force into R square divided by M square. What is forces? Force, we know that. Force times mass into acceleration. So, we can write mass into acceleration into distance square divided by what is this? Again, mass, square of mass. So, here this M and M gets cancelled. Right? Then acceleration, what is the acceleration value is? Lt power minus 2. Then square means what? L square divided by m. So everything in a square bracket. Right? So we'll write this to the higher power. It becomes to be m power minus 1 L cube t power minus 2. So that is the dimensional value for what? Our gravitational constant. Is it clear? So force is directly proportional to product of the mass, inversely proportional to square of a distance between them. The proportional sign is removed. We'll write as a gravitational G. Therefore, G is equal to, right? F into R square into M square. F we don't know, right? Again, it is what? Mass into acceleration. So, mass gets cancelled and we are writing the dimensional formulas and we are writing it. Right? Is it clear? So, it is a very important part and you have to learn that. You have to learn about the 7 fundamental dimensional values and you have to know about all the physical quantities and its formula to represent the physical quantities. And from the formulas, you have to write the fundamental quantities and from that we have to write the dimensional values. The similar way how we are writing the unit, here also we are writing the dimensional value. It is a very important one. In each and every chapters we learn different physical quantities. If I learn any physical quantity, then automatically we learn about its symbol, then we learn about its equation. From the formula we are writing its unit, dimension and we say about the whether it is a vector or scalar quantity. Then only the physics term will becomes to be fulfilled. If we are missing any one thing, it is not in a proper notation, right? So we have to learn about how to write the dimension analysis. So today we have learned this one. So we have played with a nice numbers of significant figures and dimension analysis. So and we learn about what? Rounding off also, right? We learn about significant figures, rounding off, and we learn about the dimension analysis. It is simply a mathematical calculation basis and it is a very easy concept and we have to try to understand it and try to do it all the fundamental quantities which has been given in the lesson, right? And if any physical quantity comes for it, whether in your book it is dimensional values are given or not, you try to find the dimensional values for all the physical quantities which you come across, right? So that is right. So coming Saturday, you are having a test in physics. So you are going to write your weekly test and you are going to write the measurement lesson. So prepare well for that. I hope you have understood all the topics and prepare it and write the test properly.